Everyone, welcome back. This is Kavya, and now we are going to take the second chapter or the second unit in block 1 of MPC psychology, subject MPC005 research methods. So this chapter is reliability and validity, and we'll be seeing external and internal reliability and validity here. So reliability and validity are very important two aspects when we conduct a research. So this is a very important topic. So it is important that all of us understand what these terms mean, and then we will be discussing certain types of reliability, certain types of validity. So that is the core part of this chapter. So when we do research, we have two objectives. One is to ensure that we are getting relevant information, and second is to ensure that the information that we have got is both reliable and valid. Okay, so let's understand what is meant by reliability and validity. So we are starting with reliability. So again, I'm going according to the text so that it is easy for everyone to learn. So you can just keep your text with you, the PDF or the actual hard copy book, and then you can follow these lessons. So reliability means that any result that we get when we're doing a test is repeatable. That is, if I have a test instrument and I'm doing a test, then I should be able to repeat it and get the same result again. So this is very important because only this will ensure that the findings can be believed, and this will ensure that all researchers can believe the hypothesis that I have done through my research. So this is a very important requirement for a hypothesis to be accepted by other researchers. So for example, if I'm measuring time in my experiment and I'm using a stopwatch to measure time, if I do the same experiment multiple times with the same stopwatch, I should get the same result. So the assumption is that all instruments that we are using are reliable. So if I use the same stopwatch to calculate the time of some experiment happening, it will always give the correct time. And another thing that we also do is, if I am doing the research, I am calculating the time, I could have my own judgment, my own observation. And if another person is coming and do it, there could be a slight variation. So at least within me, when I do it, there should be reliability. And that small error is acceptable. So reliability is very important, and reliability is also like a first step before we ensure validity of an experiment. So reliability is the consistency, and it ensures that if we are measuring something in the same condition with the same sample, we will get the same result. The text also gives few definitions given by certain people in certain time period. I'm not going into that. Now we are going to see the types of reliability and how to estimate reliability. So to ensure that the reliability is assured, and to make sure that there is reliability, there are two types of procedures that can be used. One is external procedures, external consistency procedures, and the other is internal consistency procedures. External consistency procedures usually will be something that is outside the experiment or the test, and internal consistency will be within the test, as the meaning suggests. So in the external consistency procedures, we have test, retest reliability. Then we have parallel forms of reliability. And the internal consistency procedures, we have split half reliability, Kuda-Richardson estimate of reliability, and Cron's alpha reliability. So we are starting with external consistency procedures. So which means that this is outside the test. So we will be doing multiple tests with the same instruments, and then we are trying to see if the test is repeatable, or we are trying to see if it is reliable. So in the test, we go to the first step, which is the test retest reliability. In the test retest reliability, what we do is we'll repeat the same test on the same sample but at 2 different times. Okay, and then we'll be calculating the reliability coefficient. That is, the reliability coefficient is a number which decides how much connected the results are between the 2 time periods. So in this, we have an assumption that with the change in time, there will not be a change in result. So it will totally depend on the test instrument only. Okay. For example, we are thinking of a intelligence test to determine what is the intelligence coefficient of a person or the IQ of a person. So if we give a intelligence test to if I am taking the intelligence test in the morning, I might get some score on it. And if I am taking the same intelligence test after some time, maybe today night itself or tomorrow morning, will I get the same result or will I get similar result? That is what this test retest reliability is. To this method, there could be certain limitations, there could be certain disadvantages. One is a memory effect. So if I took the test in the morning and then again I'm taking the test in the evening, I could remember that it's how the answer would be, because after in the morning I knew how to do it, and in the evening I wouldn't even have to do all the calculations. I can immediately remember the answer and write it. So that could be one reason why the second time it's not a very reliable way to do it. Another issue is practice. So for IQ test and all, people will be practicing for a long time. So maybe in the morning test and in the evening test, every time I'm not doing anything, I'm just taking memory from the practice itself and then putting my answers. And the third disadvantage or limitation to this test retest reliability method is absence. That is, sometimes the candidates are not ready to come back to do a test again. So I'm like, okay, I did it in the morning, now I'm not going to do it in the evening again. So then the researcher cannot have a sample to come and do it again. So that absence can also be an issue. The second external consistency procedure is parallel form of reliability, and parallel form reliability is also called as alternate form reliability or equivalent form reliability or comparable form reliability. That means there is 2 things happening parallelly together. So we are comparing. So in this, there are 2 equivalent forms of a same test which will measure the same quality or the same variable. So, but what we need to ensure is that both the tests should be of equal difficulty. For example, again considering the case of IQ test, if I have one test, if I have to measure IQ, then I have test A, which measures IQ, and I'll also need to have test B, which will also measure the same aspects of the IQ, and the second test will also be having same difficulty as the first test. So here the problem is that it is always very, it is very much effortful for the researcher to always have 2 equivalent forms of the same test. So even though this has been seen as a very good approach to ensure reliability, but this is cumbersome, this is a lot of effort for the researcher, so it's not really used so often. And also sometimes there could be I'm sorry, I kind of have doubt. Yeah, so there is also practical considerations that to find similar tests or to make similar tests, and hence a lot of time people don't do this. People don't do this method to avoid the external reliability issues. So now we are thinking about the internal consistency procedures, or ways to increase reliability through internal procedures. So when I say internal, it means it is within the test. So here there are 3 types. One is split half reliability. Split half means you're dividing something into half. So that is the clue word that you can use. So here we randomly divide all the test items into 2. So there are, if a test measures 10 parameters, we are dividing it into 2, 5 and 5. And then both these will be administered on the same population. And then we will be calculating the score that people get for each half of the test. And then the reliability score, the quotient, will be connecting between these 2 halves. So it might be a bit difficult to understand because it's not what we're used to doing. So example, there is a questionnaire to understand or an IQ test with 10 questions to evaluate your IQ. So you are giving, so I'm taking the test. So I'll be given 5 and 5 separately, and then what is my score on the first 5, that will be calculated. What is my score on the next 5, that will also be separately calculated. And then we'll try to see if there is a relation between these 2 numbers, these 2 results. That is what is known as a reliability coefficient. So this is also slightly problematic because if it's a short test, like only 10 questions, then splitting into 2 can give risk. That is compared to a long test. For example, if I have a test with 50 questions, so I'm splitting into 25. In those cases, we can ensure that the reliability will be higher, because whenever your sample number increases, the reliability will be higher. So in this book, we are also given a correlation coefficient R, which is equal to 2 into RHH divided by 1 plus RHH, where RHS is a correlation between the 2 halves of the test. And this formula is known as Spearman-Brown's formula. So these are, so when you go into the next chapter, the statistics chapter, that is where we'll see all the application of all these coefficients, and then we'll be able to understand this better. So now I think it is easy or it is just important to understand these as theoretical concepts. The next is the Kuda-Richardson estimate of reliability. So in this, they have already calculated a number which is 20, which is the Kuda-Richardson formula number 20. So here what they do is, to understand the reliability, what they do is they are trying to find the difficulty of the questions. So here they call it as difficulty index, and symbol P is used to represent difficulty index. So P means number of respondents, number of people who are taking the exam who get each item correct. That is, if 10 people are taking the exam, 2 people get every item correct, P is equal to 2. And Q is equal to number of people who get each item wrong. So maybe 2 people get all the items wrong. So that is Q. So here what they are doing is, again we have a formula here. So KR minus 20 is equal to N divided by N minus 1 into 1 minus sigma PQ by sigma square. So here, for example, they have given that if an item X has P 0.67, means it is answered correctly by only 74%. So that means to calculate this Kuda-Richardson formula, calculate the difficulty using the Kuda-Richardson formula, we have the P, we have the Q, we have the variance sigma square, and with all these n number of items on the test, you can calculate the KR value, and then you can understand if it is reliable enough. Reliability increases if the value is, the quotient is near to 1. So this Kuda-Richardson method is usable in case of tests which have answers as 0, 1 or right, wrong, yes, no, true, false, etc. So that is one limitation to the Kuda-Richardson estimate of reliability. The third option is Cronbach's alpha. So this is also similar to the previous one, and there is a specific formula given here, and this correction is called as Spearman-Brown formula. Again, here we have all the definitions given in the text. Here also what we can see is the quotient number will be varying between 0 and 1. If the quotient is near to 1, if the quotient value finally when you calculate, if the value is near to 1, it means there is high correlation quotient between the two tests, which two administration of tests, which means it is highly reliable. And this, unlike the Kuda-Richardson, here you can use it for test which has questions which measure more items, not just 0 or 1 or yes or no, but even questions like agree, disagree, strongly agree, neutral, or even things like what political party are you affiliated to. So you have some 5 or 6 options. So all of these kind of answers also you can use the Cronbach's alpha. So these were the 3 internal consistency procedures for estimating reliability. So we understand what reliability is. Reliability means the repeatability of a test and we are getting the same result after you repeat it every time. So there are external and internal procedures to understand the reliability. External procedures will be outside the test and internal will be within the test. So in the external we have the test retest and the parallel forms, and in the internal we have split half reliability, we have Kuda-Richardson reliability and Cronbach's alpha reliability. So all these 3 not just 3, 2 external and 3 internal, all these 5 reliability measures are useful and need to be decided by the researcher depending on what they are trying to understand and why they want to use this particular reliability test. For example, test retest is easier to administer, but then they have to ensure that the people will come again for doing the retest. Or if somebody has to do the parallel forms, then it is the prerequisite or the first step itself is that they have to create 2 forms of the same test. If someone is using Cronbach's alpha, it can be for tests where the questions have more than 2 answers. Or if someone's using Kuda-Richardson, it is for a test which has only 2 answers. And if you're using the split half reliability method, then you have to use a test which have lots of questions, a large number of questions. So this is about reliability. Now let's talk about validity. So validity is the degree to which a test measures what it claims to measure. That is, if a test says I'm going to measure musical ability of a person, it should be doing that and not measure the reading ability. So music, when somebody is playing a music is also written as notes. The ability should be measuring only how good they can play the music and not how well they can read the music. So that's a small example. So again, validity has a lot of definitions given by different people, different psychologists and researchers. So what we should always know in validity is the validity, for determining validity, test should be compared with some ideal independent measure or criteria. So we are going to see 6 different types of validity: content validity, criterion related validity, construct validity, phase validity, internal validity and external validity. And in these there will be certain other types also. But what you need to make sure is know that what each term means, and then it will be easier to understand, write it for the exam. So first we are going to content validity. That is, the test sample range of behavior is represented by the theoretical concept being measured. So when you hear something like this, this may seem very confusing. So to simply understand, content validity means what all content is there within the sample representation. That is what is used to measure. That is, first we need to know content validity is a non-statistical, non-quantitative method. And then what we need to know is that when you do a test and if you have to see the content validity, all the sample items, all the possible items should be there. That is, I'm going with the example given here. So all the content should be there. That is what is important in content validity. So if the researcher is measuring how well children can pronounce or children can give the spelling of words. Children studying in class 3 can give spelling of words. First, I should already know what all words they were taught in school. So I should have a full list of words that children who reach up to class 3 have been taught. So which means I need to get a list of all the spellings that they learned from class LKG, UKG 1, 2 and 3. And then only I can ask them. Then my test will have to include only those words. I cannot bring in a new word which is not within the sample. If I do it, then the test will not be accurate, because then I am not testing what a third class student will know. So it is about the content. So what content is there? If all the content is there within the test, or vice versa, that is only content that is in the only content that can be tested should be put in the test. Okay. So it doesn't mean that I have to test all the words if I have to know that whether the children know the spelling. But if, for example, if I know that there are 100 words for which children in class 3 will know the spelling, I can take some 20 or 50 or something like that, depending on my time and other logistical factors, and then give that to the test takers. So, So different people will also judge these separately. For example, I may pick few words and say that these needs to be included in the test. Another person may pick some other words. So between the people who make the test, there could be certain variations. So if you need to avoid that, then you need to find a mean set of words between two people who are making the test. That is what is meant in the last paragraph. Second is the criterion related validity. Criterion related validity means a valid test should relate closely to other measure of the same theoretical concept. That is, so here it is about criteria. First one was about the content. So what content should be there in the test? Second is a criteria, that is what criteria the test is measuring. For example, if I am having one intelligence test and if I compare it with another intelligence test, both intelligence tests should have similar things to measure, because both need to measure intelligence. For example, if I am saying musical intelligence, both needs to have musical intelligence questions, and not like first test will be asking mathematical aptitude and second test is asking musical questions. Then there will not be criterion validity. And inside criterion validity, we have two types. One is concurrent validity and another is predictive validity. So concurrent validity means if a test measures anxiety and if it has concurrent validity, it will reflect the current level of anxiety which a person is experiencing. That is, the criterion validity becomes concurrently valid if it is achieving whatever criteria is being measured is being achieved at the time of the test taking. That is, if I'm trying to measure, so I'm going with the same example. If I'm taking a test which measures anxiety, so I'm right now doing this video, so I could be having certain anxiety. Okay, how am I talking in the video? How am I facing the camera? Am I saying the right words? I'm making mistake. All these anxiety will be there. So I'm doing an anxiety test. It should give me, the test result should also show my current level of anxiety, and it should not be about some time when I was in the past having anxiety or sometime in the future. So that is meant by concurrent validity. Current, which means current time. Okay. And next is predictive validity. Predictive is something about the future. You are predicting. You are making a guess about the future. So here the criteria should be, the criterion should measure something which can be obtained later, which can be seen at a later time. For example, if I am attending an aptitude test for entrance exam, say it is an engineering entrance exam and I am attending an engineering entrance aptitude exam, I'll be asked different questions on maths, physics, chemistry, etc. And I'll be getting a certain score on this. It does not just tell me how much I know about maths or physics or chemistry or engineering at that point when I'm writing, but it also gives me a right prediction of if I'll be able to be a good student of engineering, if I'll be able to complete my engineering course, or if I'll be able to get a good engineering job after completing my course. So that is predictive validity. So we are predicting what will happen in the future. Third validity is construct validity. So we will be studying in detail about constructs in a future chapter. But just for understanding, we know what variables are. Variables means they change with time. They change during measurement. So age will change. So this year I have a particular age. Next year it will be +1. So it changes. Or age is a variable which can take different values. If my age is taken, it will be having a certain age value, and if we take your age, that will be a different value. So the value changes. That is what is meant by a variable. And construct means it is also similar to variable, but here it doesn't take a specific value. You cannot measure it. For example, happiness or sadness. I cannot say I am X years in happiness. No, there is no years. So if I say I am 30 years in my age, that is years. I can give some number and tell my age, but that cannot be same in case of happiness or sadness. So it's a slightly abstract thing, construct. So we are going to think about construct validity. So construct validity is said to be more complex than other forms of validity, and it says that a construct measurement should actually measure the construct that they are designed to measure. It's similar to what we learned about the definition of validity itself. So the test should measure the theoretical construct it is supposed to test and not something else. So a test on leadership should measure leadership and not extraversion or extraverted behavior. So a test which has construct validity should measure what it measures and not measure theoretically unrelated constructs. So for example, in construct validity itself, we have two types. One is convergent validity and another is divergent or discriminant validity. So the convergent validity means a test measures is correlating with what the theory predicts, and divergent, it doesn't correlate with the operationalization given. So these are the two types of construct validity. Next we go to phase validity. The fourth type of validity is phase validity, and as the name suggests, it refers to something that is superficial. So what appears to be measured superficially is the concern here, and it totally depends on the judgment of the researcher. So the researcher takes the test instrument, there is a questionnaire or the test instrument, and every single question in it is fine-tuned by the researcher until they find something that they feel rightly measures. So superficially, when they look at the question in the test instrument, they should feel that this will definitely measure what it is supposed to measure. So that is phase validity. Next is internal validity. In internal validity, we also learned certain threats to it. So we'll come to that later. So we just first finish all the validity. So next is internal validity. It's seen as the most fundamental type of validity. The word internal itself gives us a key that it is to do something within the test. So it considers the logic of relation between independent and dependent variables, and it estimates the degree to which inferences about the causal relationship can be understood. So that is, we are trying to understand the relation between independent and dependent variable in any experiment, and here we are trying, in internal validity, we are concerned about how logical the relationship is between the independent and dependent variable and how much it can understand the causal relationship between the independent and dependent variable. That is, we already know independent variable causes the dependent variable. So that cause relation is also to be better understood here. So if we are able to understand very well the relation between the two, then it's supposed to have a high validity, high internal validity. And the next one is external validity. And as the word suggests, external means it is outside the test. So external validity considers if the result of the test can be applied to external settings or can be generalized, can be applied to everything, every other situation that is similar here. So external validity is also based on the fact that we are not taking all people present in a population to do the study. Instead, we will be taking a small sample. So if there is external validity, it means that if a test is done on 10 people in a population of 100, and if the test in the test we can find a causal relation, we can understand the causal relation, then we say that this is valid for all 100 people in the population. So that is meant by external validity. So these are the 6 types of validity. Another important topic here is threat to internal validity and threat to external validity. So what we already know is we need there to be validity in the test that we are doing, both internal and external validity and all the other type of validity that we saw, all of it is needed. Validity is needed in the experiments. So, but we also understand that there are certain situations or reasons which can destroy or reduce validity. So those are called as threats to validity. So we have threats to both internal and external validity. So now we are going to see the threats to internal validity. So as I already said, internal validity means there should be some strong relation between the independent and dependent variable, and that relation, whatever is there, that we should be able to understand from the experiment, and there should be some logic in why we have chosen a particular independent and dependent variable. So now we are understanding what all are the threats to internal validity. So these threats include 9 different threats. So I'll be going through each of these. First one is confounding threat. So confounding means confusion. So confounding is an error that can happen when variables cannot be separated. So there will be a confused interpretation of results. So we were saying that internal validity means the independent and the dependent variable should have a proper strong relationship. The cause should be easily identified. But for example, what happens is if there are 2 variables, so like we already said about the extraneous variable in the first chapter, if there is the independent variable and then the dependent variable, but there is also an extraneous variable which we don't know exists, but that is also interacting here, then that can cause a confusion in the relationship, that can cause a confusion in our understanding of the cause-effect relationship. That is known as confounding threat. Next is selection bias. So that depends on the selection, what we are going to select as our sample. So there shouldn't be any bias or prejudice, or we shouldn't be, the researcher should not be selecting people or as sample based on their own bias. So sometimes what happens is before the test itself there could be difference between the groups, but we are because that we don't know this, we may take a certain sample and that causes an issue in the validity. For example, if we have to take for example in the case of gender, personality or mental capacities, if we, or even willingness to participate, if we take participants who it is easier to approach, or if we take people who we already know, then there could be a difference in the results and that could affect the relationship, the cause-effect relationship. So that's how that can cause a threat to internal validity. Next is history. That is, the relationship between the independent and the dependent variable should be based on the cause-effect relation that we are studying, and it should not be because of any historical events that have happened to the participants. For example, if a participant has been subjected to some natural disaster like flood or earthquake, then that can, or a political issue, then there can be difference in how they would respond to a particular situation. So history can also affect the internal validity. Another is maturation. So for example, maturation as in getting older with age. So for example, if a sample of population has been subjected to a particular test in a particular year, and now we are subjecting them to the same test after 5 years, so or 3 years, what happens is the population has matured, and during this time period that has passed, their thoughts, their responses, everything has changed. So then the test results can vary. So that is maturation. Or even it could be, these could be, permanent changes, and even temporary changes, like, if somebody is tired before doing the first test and doing the second test, or if they have experienced some illness, and then that can also change their response. So maturation can also be an issue here. It can also cause threat to internal validity due to temporary or permanent reasons. Another is repeatedly testing. So in the before case we are talking about reliability, we were saying about test retest procedure. So that is when the same test is being repeatedly done, then the participants may remember answer, then based on that they would give answers to the second test. So that can also cause threat to internal validity. Another issue is instrument change. So when instrument is being changed, that can also affect the internal validity. Another is regression towards mean. So mean means the average value, and regression towards mean means when subjects or the sample are taken in such a way that we have only extreme values. For example, if we are talking about people who have mathematical abilities, we are taking only people who are getting scores in a test which has scores from 0 to 100. If you are taking only people who have got marks say between 0 and 10, or we are taking only people with marks between 100 and 90 and 100 for the test, and then doing a test on them about their mathematical ability. If we are taking the first group, that is between people who got marks between 0 and 10, then our mean will also be just near to 10 only. It will not be anything near 50, which will be the actual mean for a test whose mark will range from 0 to 100. So that regression towards mean. So who we are taking as the subjects or as a sample, that will also affect how we get the result. So that is regression towards mean. That is, it will change. The mean value will be changing depending on the sample that we are taking for the study. Next is mortality. Mortality means death. So people who have been part of the study in the initial phase, due to death or some natural or unnatural causes, if they've died, then that can also be a reason for losing the internal validity of the test. Another is diffusion. So like what we know in science, diffusion means spreading. So diffusion effect causes, it happens when there is a lack of difference between the experimental group and the control group, or if the data from the experimental group has gone or spread into the control group, that can also give us different or wrong results, and that can affect the internal validity. Next is compensatory or rivalry demoralization. So if there is a test happening and there is a sample test group and then there is a control group, if the control group is rival or enemy, is want to fight against the test, and they all decide to give a different result than being an actual control group, then that can also affect the internal validity. So in the previous example also I was talking about control group. So control group and test group are two groups that are there for doing a test. So control group is something wherein we don't make the tweaks, where we don't administer the test, and then we see what the effect is happening. And in the test group, we give the changes to the independent variable. We tweak and control and manipulate the independent variable and see what is the effect. So that is the difference between test group and a control group. And the last threat to internal validity is experimenter bias. So experimenters or the researchers, they also have different bias. They also have different attitudes. So based on their attitude, based on what they see as important, their analysis and their data collection will change. That can change. So that can also cause a threat to the internal validity. So next is threat to external validity. So as we already said, external validity is what concerns if the results of a test can be applied to the entire population, can be generalized to the entire population, and we have to see how this can be threatened, how this can be spoiled. Okay, so how can we make wrong generalization is what we are trying to understand in external validity. And this usually happens when the independent variable is depending on other external factors. Okay, so I'm going to tell you a few examples of the threats to external validity. One is aptitude treatment interaction. That is, the sample can have features that interact with the independent variable, causing to limit generalizability. So the aptitude, treatment and interaction. So the aptitude or the attitude of the sample can cause some difference when they are being treated or they are being subject to the test, and that can give us some interaction effects or the cause-effect relations, which makes it a situation wherein it cannot be applied to the entire population. For example, if we are using volunteers for the test, so that people who are coming for the test will be already interested, so their response may be different from the general population. Or we are talking about criminals, their response to a certain test may be very different from the general population. Next is situation. So situation factor means mostly external conditions like light, noise, sound, location. All of these can also limit how much things can be generalized. So in a particular situation, if there is an external factor of heavy light or sound or something, then the test results may vary and this cannot be applied to the general population. And there is pre-test effect. That is, if the cause-effect relationship is happening or can be seen only when the pre-test is being done, then it cannot be generalized. Similarly, post-test effect, that is the cause-effect relationship, can only examined after the test is done. Then also it cannot be generalized to the population. So that's also a threat to the external validity. Another is Rosenthal effect. Rosenthal effect means when the derivation from cause-effect relation cannot be generalized to other researchers. That is, if I do a certain research and I see that okay, certain things happen, certain cause-effect relationship is there, but another researcher is doing the same test and they cannot see it. It is dependent on the researcher alone. That is known as Rosenthal effect. So all these are the threats to external validity. So now we have completed reliability and validity. So these are very important concepts, not just for research method subject, but it's also important for the statistics next subject. So it's important to understand these concepts so that it's easy to attend both these subjects, subject 5 and subject 6 for the exams. Thank you.